everyone. In this video, we're going to take a look at some of the basic properties of limits. Let's start off by taking a look at the two most basic ones, and those are the limit of a constant and the limit of the identity function. So to start off with the limit of a constant. The constant function is a function that is just equal to some value. So for example, f of x is equal to some number, and let's just call this number a. This could be anything. So for example, f of x is equal to 2. That would be a constant function. The graph of this constant function, what this looks like is a horizontal line. So somewhere along the y-axis, we have this value of a. And then to graph this, we have a horizontal line going through that value of a. So it looks like this. Okay, now let's take a look at what the limit of this function is. So let's take a look at the limit as x approaches, and we just want to approach some number c. So let's put this value of c somewhere along the x-axis. This could be positive, it could be negative, doesn't matter. But as our x values get close to that, what happens to our constant? So the way we've been looking at limits is we've said, okay, as my x values are getting closer and closer to that value of c, what's happening to these y values? And in our constant function, as we get closer and closer to that value of c, we can see up here that these function values, they're not changing. It's constant, right? So no matter where we are on here, we do end up with this value of a. On the other side, as we approach from the right, so as the x values get closer and closer to c this way, it's the same story. These y values are not changing. They're still staying at a. So what that means is the limit of the constant function, no matter what value of c we're approaching, the limit is just a. Okay? Now let's take a look at the limit of the identity function. So the identity function is the function g of x is equal to x. So it's equal to itself. If we were to graph this, this is the line that goes through the origin and has a slope of 1. So we start at 0, 0, and then at the point 1, 1, it's wherever the x value and the y value is the same. So we have the point 2, 2, like so. All right, now let's do the same thing. Let's take a look at the limit of this function. So the limit as x approaches some random number c. So again, let's put just a value on here. Let's say somewhere out here, this is the value c. And we want to find out where this is approaching. So because this is the identity function, if this x value is c, if I plug that in, this is going to match up with the point here, which has a y value that matches that, so this y value is also c. If I take a look at coming from the left side, as I approach this x value of c, as I move along my line, it looks like those function values are also approaching this value of c. And then again, if I come from the left side, so as we move along, as we approach from the left or the right side, we're getting closer and closer to c. Along my line, it seems my y values are also getting closer and closer to c. So overall, the limit of the identity function, so the limit as x approaches c of x, this is always equal to that value of c. Now using these two basic identities, we can expand upon this a little bit further. So that's what I want to take a look at next. So I have 3 other properties: the limit of a sum, a difference, and a product. So the limit of a sum says if I have, so we'll do the limit as x approaches c. So if I have the sum of two different functions, let's call them f and g. So I have two functions that are added together. The limit of this is exactly the same as the limit of each one individually. So the limit as x approaches c of f of x plus the limit as x approaches c of g of x. So the limit of a sum is the same as the sum of the limits. Okay, now connecting this back to our two basic properties, let's say we were looking at an example where we wanted to find the limit as x approaches c, and let's say the function we were looking at was something like x plus 2. So this function, this would be a line. It's got a slope of 1, goes through the y-intercept at 2. But we are able to split this up into the limit as x approaches c of x and the limit of just 2. Okay, the same thing applies for the limit of a difference. So the limit as x approaches c, now let's say I have two functions that are being subtracted, so f of x minus g of x. The limit of that difference is the same as the difference of the limits, so it's exactly the same as the sums. So the limit as x approaches c of the first one minus the limit of the second one. And again, we can connect this back to our two basic ones. So just an example, let's say we have the limit, and we'll do the limit of x minus 2. And the same idea, we can split this up so each one gets its own limit, and this is just going to make it a lot easier to evaluate. So the limit of x, and then minus the limit of 2. Okay, and the last one I want to take a look at, the limit of a product. So now this is when we have two functions that are being multiplied together. So the limit as x approaches c, and now we'll take a look at f of x times g of x. And just like the previous two we looked at, the limit of a product, this is the same as the product of their limits. So the limit of our first one times the limit of the second one. And just to give you an example, let's say we're going to take a look at the limit as x approaches c of the function, let's do 4x. So again, just looking at that function, if I were to graph that, that would be a line with a slope of 4. But now if I want to find the limit, I can split that up into the limit of 4 multiplied by the limit of just x. Now there is one corollary to this limit of a product, which is illustrated actually in my example. Whenever we have the limit of a constant times a function, that's the same as the constant times the limit. So for example, let's say we're looking at the limit as x approaches c of k times the function f of x. In this case, k is a constant. So here we had the limit of 4, which is a constant, times x. Well, because this first piece, the limit of 4, that horizontal line, the limit is always going to be equal to that constant, we can just bring that out front. So the limit of k times the function, this is the same as k times the limit. So with this combination of properties for our limits, we are able to look at basic equations, separate them out if needed, and easily evaluate our limits.